Now the subject and the tissues. The architectural design will determine the outcome, and we know that there are cavities covering and the contents, and the contents will be solid, having hard tissue and the soft tissues. Similarly, the covering can be hard, the bone or the soft coverings, then the contents can be fluid or the gas. So all these factors are variable factors. So the targeted tissue composed of skin, subcutaneous tissues, muscles, bones and cavities. So that's why the response is much different than the expected, and we cannot predict how the tissues will respond to a certain amount of energy. Like skin has elastic and plastic properties. It it is a layered structure. So its behavior is different. It absorbs the amount of energy, and then it lacerates. So this skin initially it allows to resist, it absorbs the amount of energy, and the underlying tissue can be severely damaged. So because of its elastic characters, it absorbs and transmits the energy to the lower surfaces. So the skin escapes if there is soft tissue underneath. But the skin is only damaged when there will be severe. Then the subcutaneous tissues, the fat, it provides a cushion-like effect. It also absorbs and it resists the amount of energy transmitted to the subcutaneous tissues, and it absorbs the energy being transmitted to the lower tissues. They are muscles. So the blunt weapon, when it is applied, the skin, the subcutaneous tissues, sometimes they escape the damage because of their elastic and compressibility factor, and the force is transmitted under this. But again, the amount of force will determine the outcome. If the amount of force is much higher, it can disrupt the whole thickness. So when the skin escapes, usually with the blunt weapon, when the skin escapes the damage, a bruise occurs. Bruise is the rupture of the blood vessels in the subcutaneous layers, and there is collection of blood underneath the skin and the subcutaneous tissues, and that causes bruise. There is extravasation of the blood, but the skin is intact, and the collection of blood under the subcutaneous tissues will cause bruise. Similarly, the fat have the elastic and the plastic properties. Muscles, they are another factor. Each muscle fiber, we know that it is encapsulated. So there is a bundle of muscle fibers. Each muscle fiber is encapsulated, and then again the whole muscle is encapsulated. So that's why it resists. It have the property to resist the force. But again, the damage can be directly proportional to the amount of energy dissipated. Similarly, the bones, they have got the elastic properties. When the amount of force is up to their elastic contents limits, it bends. But when the limits are crossed, then the fracture will occur. Initially, there will be fracture of the opposite side. When the bone is bent like this, the fracture will be on the upper side, on the convex side, not the concave side. But when the directly applied at the point of impact, it will be crushing. But when there is bending, the elastic properties will resist, and when it exceeds on the convex surface, there will be fracture, and then the whole shaft can be fractured. So the direct fractures can be by the application of force in the, sometimes the indirect fractures, spiral fractures, they are because of the target area and because of the contact area, the distant force, they are resulted. Similarly, the cavities behave differently. They contain fluid or the gas. So fluid are incompressible and they will distort the organ and they will rupture. The hydrostatic force traveling circumferentially will disrupt the, and the most important organs, the urinary bladder and the stomach. And it is always advised that never board a bus or car with distended bladder, because the hydrostatic force in the urinary bladder will disrupt the urinary bladder easily. Similarly, organs having air, they are compressible, but the pneumatic force can disrupt them. Another example of being force transmitted at a distant place, that is traumatic asphyxia. In stampede, the multiple person, they are compressing against each other, the chest is being compressed and there will be direct pressure on the chest wall which is unable to move, and this inability to move on the one end will be causing asphyxia, that is respiratory process is not going on, and secondly it is pressing the blood vessels, and the blood within the vessels is pushed up towards the head, towards the skull, and there will be extreme congestion, cyanosis, and even the rupture of the vessels above the site of compression. So in this case, the target area is the chest, but the resultant injuries will be looked away from the site of compression. Petechial hemorrhages and other. And the blast trauma, uh, as I have told yesterday, that the blast trauma, in this there is no contact, that for injury to occur there must be contact of a weapon to the tissues, but in blast there is no direct impact. Sometimes the splinters, the other thing, they strike, but the main damage is caused by the pressure shock waves, and it is said as a peak front, the front wave. The peak front, the front wave is traveling at such a tremendous speed that it travels through the body so quickly and disrupting all the tissues, and it can deviate from the angles, from the corners of the building. It changes the direction, traveling at high speed. So in blast injuries, the shock waves traveling at high speed, the weapon itself is not being in contact, produce enormous damage. Thank you very much.